Hello, this is the third video of the Hyperbolic Function Series 2 on inverse hyperbolic functions for OCR Pure Core Further Mathematics, and it looks at integration using inverse hyperbolic functions. Integration is the reverse of differentiation, and therefore, since in the last video we looked at the derivatives of the inverse hyperbolic functions, and we found that d by dx of sin to the minus 1 of x equals 1 over the square root of 1 plus x squared, we can therefore conclude that when we integrate both sides, we would get the integral of 1 over square root of 1 plus x squared dx equals sin to the minus 1 of x plus c. It's important not to forget the constant of integration. Similarly, for the derivative of cos to the minus 1 of x being 1 over the square root of x squared minus 1, we can conclude that then the integral of that will be cos to the minus 1x plus c. These standard results really extend the range of integrals we can deal with, so they're very useful, and they're in the OCR formula booklet in the integration table. These results are generalised further for x over a, noting that it's a squared and that also the coefficient of the x squared is only 1. For the case where we have something of the form a squared plus kx squared, when we're looking at the integral of that, we'll have to take some other steps. In this example here, we will note that we need to use the standard result for cos to the minus 1 of x over a, and we can note that a will equal 5. Therefore, without further ado, we could simply write down the answer to that integral as being cos to the minus 1 of x over 5 plus c, noting that we have taken account of the a value and we have not forgotten the constant of integration. In this example here, we can see that we've got 16 plus 9x squared, and we need the coefficient of x squared to be 1 in order to use this standard result. Therefore, we take out a factor of 3 from that square root. And by doing that, we would write that as 16 then over 9 plus then 9 over 9 x squared, which will then give us, I'll take the third out here, the form that we need to use the standard result. So that stays as 16 over 9, but that just becomes plus 1 lot of x squared. We can therefore identify that in this case the a is 4 over 3, and apply the standard result, not forgetting the factor of a third, which would be sin to the minus 1. X over a would obviously then be 3x over 4, because you've divided by a fraction, and not forgetting the plus c. So key things to remember are the fact that you must have it in this form in order to use the standard result, where you've only got a coefficient of 1 for the x squared. Don't forget the factor you've taken out. Don't forget the plus c, and do make sure that when you divide by a, you have the numerator and denominator correct. In the next video, we will look at integration using hyperbolic substitutions.